going to do in this lesson is combine what we learned about completing the square in the last lesson and solving equations using the square root property in the lesson before that. We're going to take equations that look like this, some sort of trinomial equals 0, and solve them by using the completing the square method, which combines, like I said, square root property and completing the square. So completing the square always works, unlike factoring, which I didn't show you any examples of where factoring doesn't work, but there are quadratics that cannot be factored if the b and c numbers don't work out in that way. And so, completing the square will always work, I promise. And so it's a nice method to have in your kind of toolbox of ways you can solve equations. So, just as a preface before we get into this, when you're completing the square, you always want to check to see if there's a number in front of your squared, your x squared, n squared, whatever. If there is a number in front, like you see in these two, you start by dividing by that number. If there is not a number in front, you don't have to worry about that. So, let's dive right in. There's kind of a handful of steps here, but I'll help you get through it. I promise it's not too bad. Since there's not a number in front of r squared here, the very first thing to do is I'm going to move the c, or the number right before the equal sign, to the other side of the equation. That's just like solving any other equation you've done in the past. To do that, you do the opposite. Opposite of plus 56 is minus 56. So when I do that, I'm also going to insert some blanks, sort of like you saw in completing the square process. So r squared stays the same, minus 18r stays the same. This cancels, so normally we wouldn't put anything, but I'm going to put a blank there for completing the square. Other side, 0 minus 56 is negative 56. I'm also going to put a blank there. The blanks are there to remind me that I'm going to do some completing the square process, and so a number is going to go here. It has to be on the other side as well, because anything I do to one side of the equation, I have to do the other. So, if we didn't have this, if we had just the left-hand side, this looks like what we did with completing the square. So it's exactly what we're going to do. This time, my b number is negative 18. So I need to find that number divided by 2. Negative 18 divided by 2 is negative 9. And I need to find that number squared. So b over 2 squared is going to be negative 9 squared. Negative 9 times negative 9 is positive 81. Just like when we completed the square in the past, the squared version is what goes in the blank. Anything I do to one side of the equation, I have to do the other. So since I'm adding 81 here, I have to add 81 on the other side. Just like when we did completing the square in the last lesson, I then factor this left-hand side. It turns into, since my variable is r, my b divided by 2 number, which is negative 9 squared. The other side of the equation, which we didn't have before but now have to deal with, just combine your like terms. Negative 56 plus 81 is 25. Now, this looks like things we solved with the square root property. If I want to solve this equation, the first thing I got to do is undo the squared, because everything on the left-hand side is getting squared. So from here, I'm going to take the square root. Square root and square cancel, so I just get r minus 9. Other side, square root of 25 is plus and minus 5. Remember that plus and minus 5 stands for r minus 9 equals positive 5, and r minus 9 equals negative 5. So then you're going to solve both equations. To solve, I need to undo the minus 9 by adding 9. So one of my solutions is 14, and the other one is positive 4. Notice we didn't get plus and minus the same number. That's not usually how these work out. So, kind of putting everything together from the last couple lessons. Let's retrace our steps. We undid this number here by adding or subtracting. We then did the completing the square process to fill in the blank, but I have to do it on both sides of the equation. Factor, just like we completed the square. And then we used our square root property to solve for our variable. Notice we got 2 solutions. Remember, exponent 2 means we can have up to 2 solutions. All the ones you're going to see today will have 2 solutions. All right, let's try another one. So we start by undoing this number and moving it to the other side. It's a negative 74. To move it to the other side, I do the opposite and I add 74. This cancels, but remember we're going to put a blank here. 0 plus 74 is 74, and we need that blank blank, or if you'd like to draw a box instead, whatever reminds you that a number goes here, do it. All right, this time my b number is 2. b divided by 2 is 2 divided by 2, which is 1. b divided by 2 squared is going to be 1 squared, which is also 1. The squared version is what goes in the blanks, just like when we completed the square. And then it factors as my variable this time is m. My b divided by 2 is a positive 1, so plus 1 squared equals 74 plus 1 is just 75. All right, from here we solve. To solve, we use our square root property. So undo that squared, I square root both sides. I get m plus 1 over here. 75 is not a perfect square. If you take the square root of that, you can just leave it as square root of 75. But what I'm going to do is I'm going to write it in decimal form. Again, I'll accept things either way. In decimal form, like if you type this into Desmos, you're going to get plus and minus 8.66. Remember, Desmos won't give you the plus and minus. You just have to be smart enough to remember that. Now, we know that this means m plus 1 equals positive and m plus 1 equals negative. So let's split that up and get our two solutions. All right. So to undo the plus 1, I subtract 1. 8.66 minus 1 is 7.66. And negative 8.66 minus 1 is negative 9.66. So those are our two solutions. Like I said, I'm fine with doing decimals for these ones. If you left it in radical form, just so you know what that would look like, it would be, since this became plus and minus square root of 75, you would have 1 plus square root of 75 and negative, or 1 minus square root of 75. I'm sorry, negative 1 and negative 1. So this is the other way your answers could look. I think it's a little easier, and if you were to do a real life problem, to do decimals, so we're going to do decimals. All right, last two. Process is nearly identical. Like I said at the beginning, the only thing you have to watch out for is if you have a number in front. If you have a number in front of x squared, or in this case p squared, you start by dividing by that number. So I'm going to divide the whole thing by 10. I'm allowed to divide an entire equation by a number as long as I do it to every number in the equation. It doesn't change my equation. It's a solution. So 10p squared divided by 10 is p squared. 20p divided by 10 is 2p. Negative 80 divided by 10 is negative 8. 0 divided by 10 is 0. Now that I've divided, it just makes the numbers much easier to work with. I'm going to undo this minus 8, move it to the other side by adding 8. When I move it to the other side is when I start incorporating in those blanks. My b number after I've divided and everything is 2. b divided by 2 is 2 divided by 2 is 1. Hey, look, that's the same stuff we did in the last problem. And so b squared is just 1. So we've already done the work. I'm not going to write everything out again. The squared version is what goes in the blanks. The factor, or to factor it, is going to be my variable p. b divided by 2, which is positive 1, with a squared on the outside. 8 plus 1 on the other side is 9. Now we solve. So we take the square root of both sides. I get just p plus 1 on this side. Other side, square root of 9 is plus or minus 3. We know that this really stands for p plus 1 equals positive 3, p plus 1 equals negative 3, and then we solve them both by subtracting 1. So one solution is 2, other solution is negative 4. Work-wise, again, you don't have to show every single thing I'm showing. I don't need to see all of this stuff. The b over 2 and the b over 2 squared, it helps you great if you can do that in your head without writing it down. More power to you. Also, if you want to go straight from here to here, the equation to the solutions without writing this in-between work, that is fine. For me, I find it helpful to split it up, or otherwise I forget my signs or something. One last one. So again, we have a number in front, so we're gonna divide everything by that number. That number might not always be 10, it just happened to be 10 for 2 problems in a row. 10r squared divided by 10 is r squared. 20r divided by 10 is 2r. Negative 20 divided by 10 is negative 2. And 0 divided by 10 is 0. We need to move this 2 to the other side. Since it's a negative 2, I'm going to add 2. So I get r squared plus 2r plus blank equals 2 plus blank. This time my b number is 2. And it's the same b number we've had for the last 2 problems. So I'm going to follow the same steps I did here. B over 2 squared is 1. B over 2 is also 1, so this factors as r plus 1 squared. Again, I skipped some steps here because I've had the same situation 3 problems in a row. Other side, we do have to switch it up because it's different numbers. 2 plus 1 is 3. To solve this, we take the square root. This leaves me with r plus 1 on this side. And a square root of 3 is not a perfect square, you're going to get a decimal. You can leave it in a radical form by finding decimal a little easier to work with for these problems. Square root of 3 is plus and minus 1.73 if you round it. So then from here, we need to get r by itself. I like to split into 2 equations. You don't technically have to, but I think it makes life a little easier. And then we solve. To undo the plus 1, we subtract 1. So we get r equals 0.73 for one solution. And then the other one is r equals negative 2.73. If you wanted to do that the other way, it would look like r equals negative 1 plus or minus square root of 3. That would work too. That is it for this, and this is actually the last lesson for the semester before your exam. So you've learned everything you need to know for first semester of Algebra 2. Have a fantastic day.